to session 5 of the chapter Ray Optics. Till now we have studied refraction at a plane surface. This session will be on refraction at spherical surface. Right? Okay, before I go with refraction at spherical surface, first let us understand how to draw normal to the spherical surface. Right? As we have studied, if this is a plane surface and if the incident ray falls at this point now here, this point is called as a point of incidence now here, right? At this point, if I want to draw the normal, I simply draw a perpendicular line at this point now here, and this line is called as normal. And this was the case when you had plane surface. Now we are discussing refraction at spherical surface, right? Means I am taking a surface which is spherical and I need to draw the normal at the point of incidence. How to draw? Okay, first let us learn this, then I will be going with the refraction at spherical surface in detail now here, right? So this is the principal axis now here. If I am taking, this is a ray of light which is incidenting at this point. So this point is the point of incidence, and where actually is the normal? Okay, first thing what you need to understand is normal is a line which passes through center of curvature, right? For example, if I am taking this as a spherical surface, here I will be getting the center of curvature. Normal is a line which passes through center of curvature. So this is the line which passes through center of curvature, and this line is called as normal, right? Simple. If it is a plane surface, draw a line perpendicular surface, that will be the normal. If it is a spherical surface, the line which passes through center of curvature is the normal line, right? Okay, after understanding this, let me go with the today's concept, that is refraction at a spherical surface, right? So we will be deriving the formula, right, in which we can find the refraction at the spherical surface, right? So this is a 5 marks derivation. Let us discuss about refraction at spherical surface. In the examination, the question will be asked like this, right? So it is nothing but derivation of a relation between n1, n2, u, v and r for refraction at spherical surface. The question will be like this, right? Derive the relation between n1, n2, u, v and r for refraction at a spherical surface. So today I will be doing the derivation of the relationship between these quantities from here. What are these? Okay, we will be learning in detail when I will be doing the derivation, right? So the question will be asked like this: derive the relation between n1, n2, u, v and r for refraction at spherical surface. Okay, let us start with the derivation here, right? Okay, I will be taking refraction at spherical surface. First of all, I need to take a spherical surface now here. Okay, let me take the spherical surface is like this. So this is the spherical surface which I am considering now here, right? And this is the line. This line is called as principal axis now here, right? I will be taking principal axis like this now here, right? Okay, now I will be considering this is an object now here. Let me take object O now here, right? So I will be taking a ray of light which falls on the spherical surface. Let me take a line which falls on the spherical surface. Okay, now I need to draw the normal. If I want to draw the normal, I want center of curvature. You know what is center of curvature? Center of curvature is the center of sphere of which what we in a spherical surface is a part now here. Okay, first of all I will be making it a sphere. If I make it a sphere, here what we get now here, center of curvature. I don't want this part, let me remove it. So I got a center of curvature now here, right? So this ray is called as incident ray, and this is a ray of light which falls on the spherical surface, right? Okay, this is center of curvature. So I will be taking a line which passes through the center of curvature. And what is this line? This line is called as normal now here, right? We know the angle between incident ray and normal, this angle is angle of incidence. Now let me take the medium this medium is different and this medium is different. Let me take this medium of refractive index N1 and this is the refractive index N2, because since we are speaking about refraction, light must move from one medium to another medium, right? As the light is moving from this medium to this medium, let me take the refractive index of this medium, let me take N1, the refractive index of this medium, let me take it as N2, right? For instance, let me take, this is a rarer medium and this is the denser medium. Let me consider this is a glass now here, this is air, right? For instance, let me consider like this. This is the rarer medium and this is denser medium, right? You know that if it is a denser medium, N2 must be greater than N1. Okay, you need to understand how the ray of light should behave here, right? If it is moving from rarer medium to denser medium, if a ray of light moves from rarer medium to denser medium, it bends towards the normal, right? Okay, where is the normal? Okay, this is the normal. Okay, if the spherical surface was not there, it could have gone in a straight line here, right? So since there is a spherical surface, refraction must take place and the ray of light must bend towards the normal. Okay, where is the normal? This is the normal and ray of light must bend towards the normal. Okay, I have considered this. This is a principal axis. Let me continue, and at this point it will bend here. If this is an object and this is, let me call it as image I know here, right? So this is object, this is image in here, right? It bends towards the normal, right? Okay, now if this is the angle of incidence, where is angle of refraction? Angle of refraction is the angle between normal and refracted ray. Which is normal here? This is normal, and where is refracted ray? This is the refracted ray, and let me call it as R here, right? So this is angle of refraction and this is angle of incidence. And you know how are these angle of incidence, angle of refraction? They must obey Snell's law. Okay, since refraction takes place, sin I divided by sin R must be equal to constant, and that constant is nothing but a refractive index now here, right? Okay, let me take it further now here. So this is angle of incidence and this is angle of refraction. Okay, one thing what we need to understand here is, this is, if I am taking, what is this distance? Let me take it as a P now here, right? Let me take this point as a P now here. If I am considering this now here, right? Okay, if I am considering this distance, what is this distance? The distance between, right? If I am considering this is a P now here, this is what we say now here, center of curvature, pole and center of curvature. This distance is nothing but what now here? Radius of curvature, right? Radius of curvature is the radius of the sphere of which a spherical surface is a part now here, right? So this becomes a radius of curvature, right? Okay, we know that the distances are always measured from the pole now here, right? For example, this is a point now here, right? Now, come on, tell me, what is this distance? This distance is called as object distance, right? It is the distance of the object from the point P now here, right? So this is a spherical surface and this is the mid of the spherical surface, and the distance of the object from P, that distance is called as object distance, and we denote it by U. Do remember, always we denote U by object distance. So this becomes what we say now here, object distance. What is object distance? OP. What is the radius of curvature? PC, right? So what is I now here? I is nothing but image. The distance of the image from the pole, that is called as image distance, right? So this is the image formed, and image distance is denoted by V now here, right? V is the image distance, right? So you got U, V, N1, N2 and R. We are deriving the relationship between these five quantities, N1, N2, U, V and R. N1, N2, U, V and R. The relationship between these five quantities, right? So that gives how actually the light behaves when refraction at spherical surface takes place now here, right? Okay, let us find what is the relationship between these things now here, right? Before, let me write now here, right? Okay, consider a spherical surface. Let me begin with the derivation now here. Consider a spherical surface. Okay, I need to consider a spherical surface, right? Let me consider a spherical surface. That spherical surface of radius of curvature. Radius of curvature. So what is the radius of curvature? Radius of curvature is R, right? Consider a spherical surface of radius of curvature R separating, let me take like this now here, separating two media, right? This spherical surface is separating two media, right? So separating two media of refractive indices, of refractive indices N1 and what we say now here N2, right? If I am speaking about refractive indices of two media, so what are those two media now here? N1 and N2. That is the refractive index of the two media now here, right? Okay, let me write. Consider a spherical surface of radius of curvature R which bifurcates, which separates two media of refractive indices N1 and N2. I told about R, I told about N1 and I told about N2. Let me speak about U and V now here. Okay, let U be, what is that U now here? Let U be which distance? Object distance. Let U be object distance and V be, what is that V now here? That is what we say now here, image distance, right? So I have introduced all the terminologies now here. N1, N2 are U, V. Let U be object distance and V be image distance now here, right? Okay. Now for derivation sake, let me take these angles. Let me name some angles now here. Okay, this first angle here, what I get, let me take this as alpha. This second angle, let me take it as beta, and let me take this angle as gamma. Okay, I took three angles, alpha, beta and gamma here, right? Okay, now for simplification sake, since I want to use trigonometry here, right? Trigonometric angles, I need a right angle triangle, right? For example, if I want to find about the alpha, since this spherical surface, right? For example, this spherical surface, if I am taking like this, instead of the curve, I will be taking it as a straight line, right? So this curve, right? Since this distance is too small, right? I can consider this point as P here, right? As this distance is too small and that distance is negligible, right? So instead of taking this point as P, let me take this point, right? So since this distance is too small, that distance can be neglected, right? Okay. Now, if I am taking like this, so this is a right angle triangle I get here. For alpha, I get a right angle triangle. Okay. For example, let me take this as M here, right? For example, OMP. This is the right angled triangle for alpha. Let me take. For beta, I will be taking right angle triangle PMC. So this is the right angle triangle. For gamma, MPI, that is the right angle triangle. Okay, I got three right angle triangles for alpha, beta and gamma here, right? Okay, and one thing what you need to understand here is these alpha, beta and gamma are small here, right? Okay, let me start with the derivation. That is for small angles. Okay, this is just an introduction about what we say here, this refraction at spherical surface. Now let me start with the derivation, mathematical form here, right? So in order to find start with the mathematical form, I need some space here. So let me take like this, right? For example, let me take for small angles. So what are small angles? Alpha, beta, gamma are small angles here, right? For small angles, okay, let me take what is tan alpha is equal to. Come on, tell me what is tan alpha equal to. Tan means opposite side divided by adjacent side. What is opposite side of alpha? Opposite side of alpha is MP. What is adjacent side? OP. Okay, what does that mean here? MP divided by OP, right? MP divided by OP, that is tan alpha. Similarly, let me take what is tan beta here, right? So tan beta, what is tan beta? So which triangle I need to take? CMP. This is the right angle triangle I need to take, right? So what is the tan beta? Tan beta, opposite side divided by adjacent side. What is opposite side of beta? MP. Okay, let me take now here. MP divided by PC. Okay, let me take now MP divided by PC now here, right? Okay, now let me take tan of gamma now here, right? So what is gamma here? Here is gamma, and where is right angle triangle? MPI. This is the right angle triangle. So what is the tan now here? Opposite side divided by adjacent side. So opposite side of gamma now here, that is MP. So let me take MP divided by adjacent side PI. Okay, what shall I take now here? PI is the adjacent side here, right? Since do remember, since the angles are smaller, do remember, if, okay, do understand this now here, if theta is small, you need to know this. if theta is small, right? So do remember tan theta will be nearly equal to theta, right? So you need to follow this condition, right? Whenever theta is smaller, tan theta is nearly equal to theta. Do you understand this, right? So we need to understand if even if theta is small, sin theta is equal to theta. Do you understand, right? These all things holds good, right? You need to understand this. If theta is small, I can replace tan theta by theta now here, right? Okay, let me use this concept. Okay, what is tan alpha? I can replace it by alpha here, that is mp divided by op. Let me write that implies beta is equal to, instead of tan beta I can write beta because angle is small, right? Okay, that is beta is equal to mp divided by pc. So now that is equal to, instead of writing tan gamma, let me take it as gamma because gamma is small. That is mp divided by what we say here, pi, right? So instead of tan alpha, I write alpha, beta, gamma because they are small here, right? Okay, now let us move further. Now, as refraction takes place here, right? So we need to follow Snell's law here, right? Sin I by sin r equal to constant. Before that, I need to find what is I and r here, right? So in order to find what is I, okay, just imagine here. Let me take one triangle here, which is the triangle OMC. Just remember, this is the triangle which I am taking, OMP. So this is the angle which I am taking, OMP. For this OMP, what is angle I? Angle I is exterior angle. You know that, right? For example, if I am taking like this, OMP, do you remember? This is the triangle which I am considering. Here it is OM, right? For example, OMC, let me take like this, O, and here it is M, and here it is what now here, C. What is this angle? This is beta. And what is this angle? This is alpha. And what is I? Let me take continued like this. The same thing. This I took, what is that now here? Angle I. So what is angle I for this triangle? Angle I is exterior angle, right? Okay. So let me write now here. Consider, which triangle I need to consider? OMC. Let me consider triangle, which is the triangle OMC. Do remember here, right? I have considered triangle OMC. For triangle OMC, what is angle I? Angle I is, which angle here? Exterior angle, right? Consider triangle OMC in which angle I is exterior angle. And you know what is the formula for exterior angle? Exterior angle is equal to sum of interior opposite angles, right? You know this postulate here, right? So exterior angle is equal to the sum of interior opposite angles. So it is interior opposite, this is interior angle. What is the opposite angles of interior? Alpha and beta. So here I can write like this, I equal to alpha plus beta here, right? Okay, do remember, for triangle this is exterior angle. For the exterior angle we know exterior angle I is equal to sum of interior opposite angles. Interior opposite angles are alpha and beta. So I is equal to, what shall I write here? Alpha plus beta, right? So do remember, exterior angle equal to sum of interior opposite angles, right? So do remember, I equal to alpha plus beta, right? So this I have considered here. For triangle OMC, angle I is equal to alpha plus beta, but we know what is alpha and beta. Let me substitute here. So that is equal to, what is alpha? Alpha is MP divided by OP. Shall I take like this? Plus, what is beta here? Beta is MP divided by PC, right? So I got angle I now here, right? Now, as I got this angle I, let me take this as equation 1. I will be using it later now here, right? As I got angle of incidence, now I will be finding angle of refraction. Where is angle of refraction? Where is angle of refraction? Here, right? So this is angle of refraction. So as this is angle of refraction, let me consider this triangle MCI. Do you remember? I am considering the now triangle like this. So this is the triangle which I am considering. This is angle of refraction which I need now, right? In order to solve Snell's law, I got I. Next I want R, right? So this is R, and let me take like this. So this is a line here. What is this angle? That is beta. And what is this now here? That is gamma, right? So this is gamma. This is gamma. This is beta, and this is R now here. Which is this triangle? M, C, and I. Come on, tell me. In this triangle MCI, which is exterior angle, beta is exterior angle. Shall I take that and let me consider what is the equation for R here, right? Okay. Now in the similar manner as I took here, let me consider another one triangle here, right? So let me consider here. Let me consider here. Okay. Consider. So which triangle shall I consider? Consider triangle MCI. Okay, consider triangle MCI. Okay, for triangle MCI, what is beta now here? Beta is which angle here? Exterior angle. Beta is exterior angle. So what is the formula for exterior angle? Exterior angle equal to sum of interior opposite angles. So interior opposite angles are R and alpha. So what do I get now here? Beta is equal to R plus alpha. R plus gamma, right? So this is R and this is gamma. Beta is equal to R plus gamma. But I don't want beta. I got I now here. I want R. Okay. Shall I write here itself? Okay. Let me write here. That implies what is R equal to? Shall I get the beta minus gamma? Let me consider like this. R is equal to beta minus gamma. Okay. I took R. This gamma. I took that side now here. R is equal to beta minus gamma. Okay, now come on, tell me. That is equal to, what is beta? We have beta. What is beta? MP divided by, what we say here? PC minus, what is gamma here? MP divided by, what we say here? PR. Let me take it as equation 2, that is R equal to. And this is I equal to. Right? Now, this is equation 1, I got angle of incidence. Equation 2, I got angle of refraction, right? So R is equal to MP by PC minus MP divided by PI. Okay, now I got R. Now, shall I use Snell's law? Yes, we shall use Snell's law here, right? Okay, let me continue the derivation here, right? Okay, I got R here. Let me continue, right? Shall I use from which law now here? Snell's law. Okay, what does Snell's law says? The ratio of sine of angle of incidence to the sine of angle of refraction is constant, and that constant is nothing but refractive index, right? Okay, so what is Snell's law? Sine I divided by, what we say here? Sine R. Sine I divided by sine R is equal to, so sine I divided by sine R is equal to, so refractive index of the two media. Okay, refractive index of, okay, second medium with respect to first medium. We know if the light ray moves from N1 to N2, so it is the refractive index of second medium, right? Where the ray of light will go, and next one from where the ray of light is coming now here, right? Let me take N21, that is equal to, we know refractive index, what is the formula? N2 divided by N1. Right? Okay, see here. Sin R by sin R is equal to N21, right? Refractive index of second medium with respect to first medium, right? So N21, that can be written as N2 divided by N1. As angle is small now here, I already told you, if angle is small, shall I take sin I by sin R? Let me take I divided by R. Okay, why did I take I divided by R? Because I and I are small. Already I told you, for small angles, do remember, if I am considering for small angles, tan theta will be nearly equal to theta, sin theta will be nearly equal to theta. That is the reason, instead of writing sin I took I, instead of writing sin R, I took R now here, right? Do remember, for small angles, this holds good here. That is equal to, what shall I take? N2 divided by N1. Shall I take like this, right? Now, what do I get now here? Let me cross multiply it. N1 into I, that is equal to N2 into R. Shall I take like this? N1 into I is equal to N2 into R. We know what is I. Shall I substitute there now? Okay. Now, I will be substituting equation number 1 now here, right? Okay. That is N1. Substitute now here. What is I now here? MP divided by OP plus MP divided by PC, that is equal to N2. R I got from the second equation. What is that second equation? MP divided by PC minus MP divided by, what shall I take now here? PR. Right? Simple. I used Snell's law and I got this equation, cross multiplication, I substitute what is the I value and what is the R value, right? By using this equation 1 and 2, I calculated like this. Now, the thing what we need to understand here is, OP is which distance now here? Object distance, right? So this is image distance and this is what now here? Radius of curvature, right? In order to consider these things, we need to use the sign conventions. What are sign conventions? We know distances are always measured from what we say now here? Pole, right? Sign conventions. So object distance may be positive or negative, radius of curvature may be positive or negative. How to decide that? So we need to use the sign convention. What is sign convention? Distances are always measured from pole, P now here, right? If the distance measured is in the direction of incident ray, take it as positive. If it is in the opposite direction of incident ray, take it as negative. Okay, now let me take using which convention here? Sign convention. Okay, let me take now here. This is the thing, let me take like this, applying. Since we are applying which convention here? Sign conventions, right? Applying sign conventions. Okay, let me take. Applying sign convention, first of all let me write what is OP now here, right? So what is this OP? OP is what now here? Distance U, right? Distance U, you know, distance are always measured from pole. Okay, from here I am measuring. I am measuring the distance in the opposite direction of incident ray. Okay, come on, tell me, where is the direction of incident ray? It is coming this side, means the direction of incident ray is this side. I am measuring O from this side here. So what happens to object distance? Is it positive or negative? Negative, right? So shall I take OP is minus U. Okay, come on, tell me why OP is negative here? UU is negative because distances are measured from pole. Okay, I am sitting here and I am measuring distance and I am moving opposite to the incident ray. As I am moving opposite to the incident ray, I need to take U as negative. So OP, shall I take it as minus U? Okay, next I want to write PC now here. Okay, what is PC mean? Radius of curvature. PC is radius of curvature. Is it positive or negative? Let us check it out. I want radius of curvature. Again, distances are always measured from pole. Okay, I am starting here and I am measuring till the center of curvature. I am moving this side. What is the angle of incidence? I am moving this side. What is the direction of incident ray? This is the same direction, right? It is coming this side. Means the measurement which I am doing and the direction of incident ray are same. That is why I can take R as positive. So what is PC? That is R. That is positive here, right? Okay, I got PC, then I want PI now here, right? Let me consider PI here. PI, what is PI now here? PI is nothing but image distance. Now, next here is image distance. Is it positive or negative? Okay, distance are always measured from pole. Okay, I am measuring from here till the image. So this is the distance how I am measuring, and I am measuring the direction is in the direction of incident ray. So PI should be taken positive. So V should be taken positive. So I shall take it as V. Now let me use these sign conventions in the above equation. Okay, what happens now here? Let me take N1 into bracket MP divided by what is OP? OP is minus U. Let me take it as minus U. Next, plus MP divided by what is PC? PC is R. Let me take it as R. Right? So that is equal to, what is that now here? N2. N2 we are taking now here. That is, what is MP divided by PC? What is PC now here? That is R. So let me take it as MP divided by PC. PC is R now here, right? Again we have minus here. Let me take it as minus MP divided by what is PI? PI is nothing but V, right? Now I have applied sign conventions to this equation, right? So I use sign convention and I have converted this and I have taken these values, right? I substitute the values, right? So using sign conventions, I got this equation. Now, if I see this equation, I got all the values now here, right? I got U, I got V, I got N1, I got N2 and as well as R now here, right? If you observe this equation, MP is common, right? If I remove MP, what do I get now here, right? So I will be removing this MP now here. MP get cancels here, right? So instead of taking MP outside and getting cancelled, let me write simply directly, right? Instead of taking like this, shall I cancel here itself, right? Okay, so that I'll be getting this equation N1 into bracket 1 divided by minus U plus 1 divided by R, right? that is equal to n2 into bracket 1 divided by r minus 1 divided by v now here, right? Instead of taking mp common and cancelling it out, I cancelled there itself. So I got this equation now here, right? Now what shall I do? So what do I get? Let me convert this, that is minus n1 divided by u. I will be multiplying this plus n1 divided by r, that is equal to, what do I get now here? Again multiply n2 divided by r minus n2 divided by what we get now here? V, right? Now I will be taking this term to this side. What do I get? n2 by v, this will remain here, n1 divided by u. I take r terms that side here, right? So here what do I get? n2 divided by r, this term to that side, n1 divided by what we said here, r, right? So by this we can write like this, since r is common here, let me take like this, n2 divided by v minus n1 divided by r. Let me take r like this, n2 minus n1, and this is the equation for refraction at spherical surface. If refraction takes place at spherical surface, this equation holds good. n2 divided by v minus n1 divided by u is equal to n2 minus n1 divided by r. So what is this n2? It is the refractive index of the second medium. Okay, what is second medium? It is a medium through which the light moves now here, right? So after refraction, the light moves in the second medium. Okay, shall I say like this? What is n2? Refractive index of which medium? Refractive index of second medium divided by what is v? V is image distance. Image distance, right? Refractive index of second medium. So yeah, the medium at which the light moves after refraction, that is second medium. Let me take in that way now here, right? Refractive index of the second medium divided by image distance minus right? Okay, instead of writing this, I need some space. Let me write like this: refractive index of the second medium divided by image distance minus what is this now here? It is refractive index of the first medium, right? This is a medium, right? So refractive index of first medium divided by what is u? U is object distance. U is object distance. Simple. See here how to remember this equation: refractive index of the second medium divided by image distance minus refractive index of the first medium divided by object distance. That is equal to what is n2 minus 1? Difference, right? It is the difference of refractive index, right? So that is refractive index of second medium minus refractive index of the first medium, right? It is difference of the refractive indices divided by what is r? R is radius of curvature. R is radius of curvature. So this is the relationship between n1, n2, u, v and r. Simple, right? The relationship between n1, n2, u, v and r is n2 by v minus n1 by u is equal to n2 minus n1 divided by r, right? So instead we can remember like this also: refractive index of second medium divided by image distance minus refractive index of first medium divided by object distance, that is equal to difference in the refractive indices divided by radius of curvature, right? Like this also you can remember. Remember, whenever refraction takes place at the spherical surface, I can use this equation, right? So this derivation is the derivation of relation between n1, n2, u, v and r. So this is the end of the derivation.